Grade 5, MX18, Lesson 4.1 from the Multiplication with Whole Numbers and Decimals unit. Hello students and families. This video resource can be viewed as a reminder of learning that happened in the classroom, a review of learning that was missed during an absence, a preview of new learning. Remember, this video cannot replace the math conversations and group learning that takes place in the classroom. If you have questions or would like additional practice, please speak to your teacher. Additional resources are available on the Think Central website. Ask your classroom teacher about how to access this site from home. By the end of this learning activity, students should be able to say, I can shift place values when multiplying by 10. Here are some of the Tier 3 vocabulary words that will be used in this lesson. Keep in mind that these are not the entire list of vocabulary words for this lesson. This unit begins with a lesson on place value and number concepts. Some of our reference points will be familiar. They are 10, 100, and 1000. Notice how each reference point is a multiple of 10. Let's use a visual reference that most of us are familiar with. Here is a dollar bill. Its value can be represented as one whole and no decimals. Using our multiples of 10, we will see how the place values shift as we multiply. First, we will multiply $1 times 10. Notice that the number 10 has 1 0, and the decimal point shifts exactly one place value. The product is $10. Next, we multiply $1 times 100. Notice that 100 has 2 zeros, and the decimal point shifts 2 place values. The product is $100. Finally, we multiply $1 times 1000. Notice that 1000 has 3 zeros, and the decimal point shifts 3 place values. The product is $1,000. This pattern of place value shift will work with all numbers. Let's try with a different amount of money. Here we have $243. If we were to multiply it by 100, what is the new amount? The number 100 has 2 zeros. We shift the decimal 2 place values. Our new amount is $24,300. The strategy of counting zeros when multiplying will also work with large numbers. Question: how many zeros do you see in this problem? There are 3 zeros altogether. Notice that when we solve, the answer also has 3 zeros. Think 6 times 3 times 1000. Here is another example. Question: how many zeros do you see in this problem? There are 4 zeros altogether. Notice that when we solve, the answer also has 4 zeros. Think 2 times 3 times 10,000. We are now going to explore another way to write these reference numbers. Exponents are an option when working with multiplication. Exponents are always written as a smaller number next to a base number. In the example above, instead of saying 10 times 10 times 10, we can write it as an exponent. 10 is our base number. We raise it to the third power, meaning we multiply it by itself 3 times. Note how the 3 zeros from the expanded form mirror the exponent. Let's try another example of an exponent. Here we have 4 tens multiplied together. 10 is our base number. We raise it to the 4th power, meaning we multiply it by itself 4 times. Note how the 4 zeros from the expanded form mirror the exponent. With any place value shifts, mistakes happen when working too quickly. Here we have many zeros to keep track of. If we forget to count just one place value, the answer will be quite off. This would be a very costly mistake in accounting. Let's look at problem number 5 from the homework. How many zeros do you count? How many zeros should be in the answer? The correct response is 2. The answer is 4,800. Here is a reminder of the learning target for today. As always, if you have additional questions or if you would like more practice, please talk to your teacher when you return to the classroom. As we continue to build this resource for students and families, any feedback that you have would be appreciated. Feel free to email with any suggestions that you may have.